I'm Dumitra, I'm a SOC analyst at Adobe. I work in InfoSec for about, I've been working in InfoSec for about 4 years. I'm a proud member of the community, and you probably saw me around these meetups a few times. And yeah, on my personal side of the life, when I'm not doing security, I'm a slave for a cat.
Hey guys, as for myself, nice to meet you. I don't think I've been here before. So, I'm senior security software engineer at Adobe. I've been in the industry for more than 10 years. And of course, I'm an info security enthusiast, especially regarding cryptography. So if you want to talk about that, I'm fine. If you know that crypto stands for cryptography, not cryptocurrency. So it will be good. Thanks.
Yeah, technology. So first of all, let's talk a bit about Kubernetes. How many of you are familiar with containers and Kubernetes? Awesome. So because of the previous talks, when I went way too deep into Docker and the technology underneath it, I tried to simplify the definition for Kubernetes as much as possible. So the very basic and simplistic definition I found about Kubernetes is that it's a portable, extensible open source platform for managing containerized workloads and services, and it facilitates both declarative configuration and automation. Well, a bit more simplified than that, Kubernetes helps you deploy containerized application in highly available clusters that work together as a single computer. Okay. I'll try to cover a bit about how Kubernetes clusters work. Link to the previous definition you saw on the slide. When you want to deploy an application in Kubernetes, you need to serve it a YAML file in which you actually define a desired state. From there, that file, you serve it to the master. The master is the one that actually manages the cluster. The master coordinates all the tasks on the cluster. That means scheduling applications, maintaining the desired state, doing any updates on it. And the file that you push to the master is then transformed into tasks that are sent to the nodes. The nodes are actually VMs or even physical computers that are workers in this cluster. And they have on them a kubelet that actually helps, it's an agent that helps the communication between the worker and the master. The node talks to the master through an exposed API. And the API that is exposed by the master is called, of course, Kubernetes API. Okay. I'm missing some text there. Okay. Yeah. So about the threat model that you can expect on a Kubernetes cluster at this moment. First of all, there are external attackers. So there are some people that might have done some research on Kubernetes, the ports that they can target, the services that are public and they can target. You can get some vulnerabilities in your application that can be exploited, and then the attacker might land on your container. And that leads us to container compromise. The latest fashion, or the more common fashion to compromise a container, is to actually look for Docker sockets mounted, and then just go and execute, escape the container, and get root on the host. And last but not least, and unfortunately the most common one, compromised user credentials. As we heard earlier, all those simple passwords, and let's not forget all the pushes to Git with keys in it. Okay, so what is the Kubernetes parameter? The external facing ports. I tried to scrap down all the ports that are connected to third-party software that you might add into a Kubernetes cluster, and we remained with this one, with these ones. 443 for the Kubernetes API. It can also use 6443, 8443. In the previous versions of Kubernetes, They also had 8080, the insecure version of the Kubernetes API. And we also have 10,250 for the kubelet that allows you read and execute on the kubelet, and 10,255 which allows you only read-only access. Now that we went through this scarce information about Kubernetes, oh, one more thing, yeah. Sorry, I have a question for you all after. So these are the hacks that we've seen in the wild in 2018. I think the most well-known is the one from Tesla. What they did was deploy a Kubernetes cluster and leave the Kubernetes platform, the console, open to the internet without authentication, which actually provided the attacker access to the master with all the information in there, even the keys for the AWS account. So instead of actually making more money from that, they went ahead and deployed cryptocurrency miner on Tesla's infrastructure. There was another security incident which I couldn't find that much information about. It was mentioned by Google engineers that actually work on Kubernetes at the latest KubeCon. At Shopify, a researcher was able to access the kubelet and get the credentials. We still don't have the full write-up. I'm not sure if we ever going to have it, but I hope it was fixed in the latest releases. And there is another vulnerability that actually kicked off our work together and trying to hunt for what an attacker sees in our infrastructure. The kubelets, the ports to the kubelets actually allowed for remote code execution and sending commands without authentication. So, with all this scarce information, once again, how would you start hacking a Kubernetes-based infrastructure? Where would you start? Okay. How would you know what are the IPs to scan for or to look for? So well, that's a part we're going to see later. So what you have at Adobe, and it's an open source tool. It's called Marius. What Marius does is basically you give it a root domain, and it will search for all the open information it can find and make DNS queries, and save everything nicely in a database that you can use at a later time. It's a project to track an organization's internet-facing footprint from the perspective of a third party, of an attacker. So you can basically find out what attackers can, what IPs the attackers can find by making some DNS queries from your public DNSs or third-party DNSs. And because most of our infrastructure is not only in data centers, and we couldn't get all the data from Marius, we leveraged another tool that we use, Mavlink. Mavlink is not yet open source, but there is a security blog about it from its creator, where it shows the entire flow. What Mavlink does, it's basically a Lambda function in AWS that queries all our cloud accounts and gathers all the data that we need, including the IPs, logs, cloud logs, and everything. But we mainly focused on the IPs. That's how we put together all our external footprint in the cloud environment. Okay, and because you said scan the entire internet, because we didn't want to go ahead and scan the entire IP block that is owned by Adobe, and we actually didn't want to input the data into Shodan, we tried to leverage it in another way. I'm gonna make a stupid question. Is there anyone here that doesn't know how Shodan works? No, right? Yeah. Oh, okay. So, as Dan said, Shodan basically scans the entire internet, and it stores the data there. So if you have anything vulnerable, you could probably find the IP there, and the service is running on it. It doesn't get too intrusive, but you can get the data and, for example, Kubernetes ports if you need to. And what is awesome about Shodan is that it exposes an API that makes automated searches way more easier. So now, more about our project. We called it Project Coast Guard. Marius will explain exactly how it works.
Thank you, Dumitra.
Here.
So, as Dumitra said earlier, you know that in order for us to be able to determine and detect if in our infrastructure we have any containers open to the internet, we tried to find a way to identify them. That's why we had an idea last year about starting this project. It was actually based as part of an internal hackathon. No, this one. Okay, so the actual ports that we are interested in were 10 to 150 and 10 to 155 because these are for kubectl and are mostly used by everyone. That's why these were the first one we tried to see if they are in the wild. This is where Shodan was used for. We started searching for this kind of open ports available on the internet, and we had to compare them against our internal database that we have by using Marius and Mavlink. Okay, considering the amount of data that we had to process, we also had a bunch of IPs to match against. The solution to store this huge list of IPs was to use Redis for that, because Redis is an in-memory key value database, and it is very fast and powerful. That's why when we were doing the comparisons, each operation would have been in the O1 time. Also, we wanted a way to be notified whenever a new result is found that matched one of our internal IPs. And the first solution that came to mind was to use Splunk and to have all these matching IPs stored in Splunk and be notified whenever we find one. We use Splunk on a daily basis because it's super powerful and it is easy to configure and set up all kinds of notifications and alerts, send alerts via email, Slack channels, or any other kind of services that send alerts. Okay, so for implementing our idea, we used Python as a programming language. The first step in making this work was to grab the data from Marius and Mavlink. Of course, this data is not in a easily format to process, so we had to spend some time and organize this data to make it easier for us to analyze it after that. This was also the step where we populated Redis with all the information that we got, and this of course changes whenever we get new info from Marius or Mavlink. So after we are searching for ports of interest, like we said earlier, 10, 20, 50 and 20, 55, we run this on a daily basis to see if there are any new findings, and we compare them with our data that is stored in Redis. We use, of course, the Shodan API for this. As a side note, you will need to have some premium credits on Shodan to be able to use the API for all of these searches, because otherwise you wouldn't be allowed to do it. Yeah, so keep that in mind. Of course, like we said earlier, whenever a new match is found, we decided to go the easy way and log them to disk, because we have it configured such as any anything that is saved in those logs goes into Splunk, and this happens in real time. We are very happy about the solution. That's why it was a no-brainer when we had to decide what to use for this. After we configured Splunk with how to send the alerts, it's all magic. Okay, I think this is the part where we have a small demo on how this works. I don't know how to. Let's see if it works. Hopefully you can see anything. Yeah, so like we said, this runs on a daily basis, and whenever a new matching is found, it is saved. Of course, this is the moment when it goes to Splunk, and in real time we are notified about the findings. Keep in mind that this is just dummy data because we didn't want to expose anything. Yeah, but that's the process. That's how it goes. Okay. I think that was our topic for tonight. If you have any questions or answers.
So if you have any questions, here's the microphone so you can be heard on the live stream as well.
Am o întrebare, voi vorbi în limba română.
Okay.
Sper să se înțeleagă. De ce nu s-ar folosi pentru accesul la Kubernetes o cheie privată, de exemplu, pe portul respective, ca să nu...
Ar trebui să folosească. De ce nu se folosește? E o întrebare foarte bună.
Da, așa, unul la mână. Și doi, de ce nu s-ar pune pe serviciile respective un serviciu invers, care verifică la un server privat, ca să spun așa, și spune automat dacă este sau nu pe internet Kubernetes respectiv conectat, ca să zic așa. Adică invers, mă refer. Din interior către exterior, nu din exterior către interior.
Noi am vrut să vedem exact ce se vede din perspectiva unui atacator. Că așa ar fi fost mai simplu cu un vulnerability scanner, identificam imediat tot ce trebuie. Ideea din spatele proiectului a fost atunci când am văzut prima dată posturile pe Twitter și diferite bloguri despre cum se exploatează porturile respective deschise, au fost ok, noi putem să aflăm rapid ce se întâmplă, dar hai să vedem cum se vede din perspectiva unui atacator. Și atunci am urmat toți pașii ăștia. Ok, care sunt pașii unui atac? Prima dată, hai să aflăm IP-urile. Ok, cum pot afla ei IP-urile noastre? Și de acolo s-a construit mai departe.
Am înțeles, mulțumesc.
So I have a question for you. Is this like open sourced? Can we use it or just internal tools?
This was internal.
It was internal, but I think we should. Yeah, my manager shows okay, so we will probably submit it to be open source, but we need some legal approval.
Yeah.
It will probably take about 2 weeks, but we can keep in touch.
How does Marinus work behind the scenes?
So those are basically some cron scripts that query some well-known sources. So basically it's kind of the same.
It tries to think like an attacker. How would an attacker scan the data it knows about target? And it goes in all the places.
Dumps DNS data and everything. It's actually open source. You can check the code on GitHub and see exactly. I don't know the exact servers it reaches to make the queries, but I'm sure it's in the code.
Am văzut că în principiu vorbim de perimetru global, adică la nivelul internetului, dar probabil că există mai multe clustere și zone intermediare
Cu siguranță.
care,
Nu așa
Accesul-
infrastructura noastră, nu.
mă rog, nu vreau să intru în detalii vis-a-vis de cum arată infrastructura lui Adobe, dar vorbesc în general, clusterele de Kubernetes sunt niște, să spunem, insule într-o infrastructură mai mare.
Da.
Perimetrul între insule este și el scanat sau vorbim doar de din
Din extrem.
internet
Din
către
extrem.
insule respective? Că probabil că, știu, cea mai slabă verigă lovește
Da.
și dacă din zonele celelalte ai acces, asta vreau să înțeleg dacă cumva
Nu urmărește asta. Nu
un
urmărește
scan și între, să zicem, între DMZ-uri sau între...
nu urmărește. Dacă nu, noi nu urmărim. Noi am vrut să vedem doar cum se vede din perspectiva unui atacator din afară.
Okay.
Ce ai putea să faci să verifici asta? Există un tool care a fost open sourced de Aqua Security prin octombrie, se numește Cube Hunter. El este mult mai activ și agresiv în scan și încearcă chiar să execute lucruri, deci ai putea să încerci cu ăla.
Ok. Mersi frumos.
Okay, this is weird. You said at the beginning of the presentation that you have a question for us at the end. Was that the Tesla one?
No, it was the one about the attack.
Ah, okay.
But
so
thank you, you're a good friend
Yeah.
for putting me in the best
So
spot.
my question would be like, is there any implementation of any anti-reconnaissance stuff? I mean, it automatically detects when someone tries to perform a reconnaissance step? Ish? Like Nmap?
Yeah. So
Yeah.
there's another tool open source by Adobe called
It's
Hubble.
not Flash Player, right?
Sorry,
Yeah.
that's the line. My manager's in the back.
Yeah. And now to troll you, I have a question about Flash Player.
No. So
Okay.
yeah, there's actually another tool open source by Adobe for monitoring Linux hosts that actually looks for that kind of data. It's based on Facebook's OS query, and all the data that OS query sees about containers, you should probably see and the hosts, you should probably see if something hits your node on that port.
Probably.
Yeah.
Yeah, it has its up and downs, I get it.